So, we have our data in the worksheet. Now we need to start actually coding the template. We'll add a new button. It's going to be the only one we add for a while. Before we assign a new macro to it, let's create a new code module and we'll call it main application. Here, we'll add a new subprocedure called create SAP model. This will be the equivalent of a main in Java programming, for example. It is supposed to be where our most high-level code runs, and we'll be calling most of our specific auxiliary subfunctions here. The goal of this is, besides keeping our code somewhat concise, to easily understand the whole workflow of our function at a glance. Before we start coding things specifically here, let's also add a new code module called SAP 2000 utils. This will be where we will put most of the code that will be directly interacting with SAP 2000. The first thing we'll need to do is to, obviously, start a new SAP 2000 instance. Let's create a new function for that. This function will also return the created instances model since that's what we'll be needing and using most of the time in our main function. We don't really have any use for the helper or the SAP 2000 object itself in the main function. A function is almost the same as a procedure. The only differences are that it returns a value, where procedures don't, and that it is defined with the function keyword instead of the sub-keyword that's used for procedures. Okay, let's fill this function out as we did previously. We'll make a few adjustments before we move on. First, for simplicity's sake, we'll be working with metric units. Secondly, we'll change this function so that it receives a folder path to where we want to save our SAP 2000 model. We'll create a new blank model with the new blank function. Now, let's check if the folder we gave the function actually exists with the dir function. If this function returns a blank string, that means the folder does not exist. And, if it doesn't exist yet, we'll create a new folder there using the mkdir function. Finally, let's preemptively save our SAP 2000 model to a file called test inside the folder we've assigned. We don't need this for now, but let's leave it in place anyway since we'll need it later when we want to run an analysis of our model. It's also helpful to save our model to a file in its own folder since running an analysis in SAP 2000 generates a lot of temporary files that can make our folders quite messy. Let's assign the return value of our function by using the set keyword since we are returning an object variable and setting the function itself as the SAP 2000 model. Going back to our main function, let's first declare a return variable as usual. Then, we'll add a little code separator. This is just to keep our code more organized in longer functions. Let's declare a shell object. This is essentially an object that represents a command shell. We're not going to run any commands on it, we just need it because we'll save our file to a folder on our desktop, and the shell object knows where the desktop folder is. Let's now code our grid structure function. This function will receive our SAP 2000 model, the number of stories, number of X and Y aligned bays, and the actual story heights and bay lengths in array form. On a quick side note, you may see that we have the byval and byref keywords when declaring function arguments. Byref is the default for passing parameters. It gives the function the actual memory address of the variable we're passing, and it means that the function can change the value that's stored in the variable itself. By val copies the value stored in the variable and does not allow for any changes in value. We can ignore this most of the time as VBA assumes that we're passing parameters by reference and not by value. However, when working with objects, arrays and strings, we are forced to pass them by reference as that is their nature in programming. Now, we'll need some variables to cycle for stories and bays and also some element creation variables for our frame objects. Next, we'll create two new rectangular frame sections for columns and beams using the C30/37 concrete. Then, we'll declare a new default rebar material. And we'll use it to assign rebar properties to our column and beam frame sections using the SetRebarColumn and SetRebarBeam functions respectively. These functions have a lot of parameters and we don't have time to extensively review them all, but you're free to do so by checking the SAP 2000 API as usual. Now, let's write our cycles for each of the stories and bays. And let's set our starting coordinates for each cycle. As well as our increment for each cycle that we'll get from the respective arrays. We can now call the functions to add frame elements to our model with a few caveats. We'll add vertical and X and Y align frame elements. However, we won't add vertical frame elements when we're in our last vertical cycle. And we won't add X and Y align frame elements in our first vertical cycle. We also won't add X align frame elements when we're in our last X cycle. The same applies for our Y align frame elements for our last Y cycle. Notice how we're doing one more cycle for stories and bays than the actual number of them. This is because we need to put frames at the start and end of each of our grid divisions. So, for example, if we have a building with a single cell, essentially a cube, we'll still need one more frame element for each dimension. And we'll fill the start and end coordinates correctly for each element. You can verify that these are correct as you'll have access to the finished code, but, for now, just trust that this makes sense. Let's also add a view refresh to the end of our function just to make sure SAP 2000 is showing us the added frame elements when we finish. Next thing we'll need to implement is a couple of helper functions to aid us in getting our data from the worksheet. Let's code these two functions very quickly. We'll need a function to get the value count from a column that starts at a cell and goes downwards until it finds an empty cell. We'll also need a function to get numerical values from a column into an array. We could use the Excel range functions for this, but we don't know the number of values beforehand, so we need to cycle cells until we find an empty one that will signal the end of our value sequence. Okay, we're just finishing up. Lastly, we need to declare our variables for getting the data from our worksheet and fill them with said data. And we'll call our grid frame objects function with our data. Great! We're all set up to test out our code. Let's just do a couple of tests to verify that everything is running smoothly. First, we'll test our code with a regularly spaced model. All good. Let's now test it out again by making a couple of stories and bays have some different values to make them stand out from the rest. And, success! We now have a working macro that allows us to create a grid structure with custom distances between stories and bays. Obviously, this is quite bare bones for the moment, but next, we'll be iterating upon this to make it a fully functional custom template.